Hello everyone, welcome back to Olsen Cafe. Now today let us revise on binomial theorem. So in today's lesson, we are going to find the coefficient of a term, in this binomial expansion. So let's begin. So over here in this expansion, you notice that there are two terms. So what we are going to do, is to focus on the left term first. So to do this, we will consider the general term. So the general term will give us r plus 1 term equals to ncr times a to the power of n minus r and times b to the power of r. So in this case, n equals to 8 and a is equals to 3 over x squared and b is equals to x. Now, putting all these together, our r plus 1 term, will give us 8cr times 3 over x squared to the power of 8 minus r and times x to the power of r. Now, once you have this formula, what we are going to do is we are going to apply laws of indices, to put everything together. So what we have is 8cr, and then I manipulate the 3, so I will get 3 to the power of 8 minus r, and for the x, it will become x to the power of negative 2 times 8 minus r. Then the last one remain x to the power of r. Now, so over here, you notice that, we can combine x together because x is the same base. So by using laws of indices, I'm going to apply and simplify this. So what we have is r plus 1 term equals to 8cr, 3 to the power of 8 minus r and x to the power of 3r minus 16. How did we get 3r minus 16? So you can see minus 2 times minus r, this will give us plus 2r. So plus 2r and plus the r again, that is how we get 3r minus 16. Now, this is a very important skill that all of you need to have, in a lot of the O-level questions, these important skills on the general term will be tested. We have found the general term on the left, so let's combine, this with the term on the right. So let's put all this together. So let me write it down. So this is the general term, putting together with the term on the right, which is 5 minus 2x. So what we want to focus now, it is only these two terms, because we want to find the coefficient of 1 over x to the power of 6, isn't it? So we just want to focus on this. So to do this, when we expand, you will see I have the minus 2 times, the term here, so I get a minus 2, and then with the index of x, I have 3r minus 16 times x to the power of 1. So by combining these two together, I will have 3r minus 16 plus 1. So therefore, it gives us 3r minus 16. So this is what we have, for the term after we multiply these two terms together. Now, let's take a look. You notice that we can actually rewrite, the index of the term of this term here. So that means 1 over x to the power of 6, is the same as x to the power of negative 6. Now, by doing this, that means we know that this x to the power of negative 6 has to be equals to x to the power of 3r minus 16. So this will be able to help us to find the value of r. So therefore, putting all this together, so I can solve for r, which is equals to 3. So simply I equate the index and then I move minus 15 to the right, and I just solve this simple equation. I will get r is equals to 3. Now that we get the r, so to find the coefficient of this term, it is simply I am looking at the numbers in front of x. So doing this, that means I will have coefficient of x to the power of negative 6. All I need to do is I simply replace the r by the value 3. So putting all this into the calculator, I am able to get the value which is equals to negative 81648. And we are done. So I hope you find this method very useful. So for questions like this, most of the time you will you will be required, all right, to apply the general term, all right, for you to find the specific coefficient of a term. Hope you find this video useful. All right, do like and subscribe if this helped you. All right, do share it with your friends too. I will see you in my next video. Bye.